Welcome to MCB Chem Tube online chemistry tutorial. And in today's lecture, I discussed to you about chemistry of carbonyl compounds, some named reaction like Stobbe, Benzoin, and Benzoin condensation. First one, Stobbe condensation. As you know, Claisen condensation. In Claisen, there are many types of reactions, and in one case an enolate of a ketone condense with an ester by displacing alkoxide from an ester. But if you are using diethyl succinate, that is a diester, it behaves differently. It forms the enolate of succinic ester is added to the carbonyl. Here in Claisen, enolate of ketone is added to the ester. But if you are using diethyl succinate, enolate of succinic ester added to the aldehyde or ketone or carbonyl in presence of base, and it give alkylidenesuccinic acid. This is the example. Carbonyl and diethyl succinate, presence of base, it form alkylidenesuccinic acid. Coming to the mechanism, first enolate formation, this is the diester. In presence of a base, it forms this one, get enolated, and this enolate of diester will be added to the carbonyl and it form an intermediate alkoxide like this, and this intermediate alkoxide can undergo an intramolecular cyclization because it contains a nucleophile and an electrophile. This nucleophile added to the electrophile and form a lactone structure. Then this one expel ethoxide and it form carbonyl. Then in presence of base, ethoxide base, this can deprotonated and this can form a double bond by expelling this CO carboxylate from here by breaking CO bond. So a structure like this it can expel this carboxylate. Finally, a highly stable structure will be formed. Another example, this carbonyl, aromatic carbonyl ketone compound, on reacting with the diethyl ester in presence of a strong base, potassium tertiary butoxide, it forms an ester like this. Final product will be like this. If you look at closely to this reaction, you can see that very simple reaction. This is a very simple reaction. What happens to this reaction is a dehydration occurs, that is condensation. Condensation of water occurs in this particular case. So two hydrogen from this carbon and oxygen from here get dehydrated. That is the one change. And another change is one of the ester get hydrolyzed and become carboxylic acid. And if dehydration is occurring from this carbon, other ester will be hydrolyzed. This ester will be hydrolyzed. So if you see any compound reactant, you can predict the product of Stobbe condensation. In this particular reaction, this carbonyl and this hydrogen get dehydrated. If it get dehydrated and forming double bond, this ester group get hydrolyzed. This ester group get hydrolyzed. And second example, in this carbonyl, cyclic carbonyl group, ketone group, on condensation with the diester, dimethyl ester, succinic ester, and if this hydrogen is condensing with carbonyl and this part, other CH2, CO2H, this part get hydrolyzed. One more example, and cycloketone, and same mechanism is same as the previous one. Then finally you get this product. And I've given two more examples here. And this is the nitrobenzaldehyde on condensation with one of the on succinic acid, and can undergo condensation, this carbonyl and hydrogen, and it form corresponding compound. And this is another example for Stobbe condensation. And what is the application of Stobbe? And this Stobbe can be used for the extension of aromatic ring. For example, this compound reacting with the diethyl ester, and finally it form this next product will be this one, and this compound can undergo Friedel-Crafts acylation reaction and intramolecularly Friedel-Crafts acylation. So this benzene ring can attack this carbonyl and a ring enclosure occurs. And here on reduction, this carbonyl can reduce to hydroxy compound. Once this hydroxy compound is formed, this can easily dehydrated. Why it can easily be dehydrated? Because it is after dehydration, it is forming an aromatic compound. So it can, and aromatic stabilization can be occurred. So this is the application, and ring extension can be done by using Stobbe condensation. Next one, Benzoin condensation. It is also called benzoin aldehyde condensation, and it is a carbon-carbon bond forming reaction. Here in this reaction, aromatic aldehyde undergo an addition. It is an addition reaction with the cyanide ion. It gives acylloin, not cyanohydride. Actually, when Cn minus added to a carbonyl, usually it forms cyanohydride. But aromatic aldehyde, if you add Cn minus to the aromatic aldehyde, it undergo addition like this. It forms a product called benzoin. In benzoin structure, you can see that one of the carbonyl it retained, and other benzaldehydes carbonyl it added, and it become hydroxy compound, and a new carbon-carbon bond is formed. So this is usually occurs, this type of reaction with aromatic aldehyde, and also it can formed by glyoxal. And coming to the mechanism, and when a cyanine Cn minus is added to a carbonyl, it forms usually cyanohydrin like this. And when you have an aromatic group and cyano group into it, here this carbon become more acidic, and this hydrogen is more acidic. Then this hydrogen can be removed in presence of a base itself. So it occurs a reversal of polarity occurs here because of this cyano and aromatic group. This carbon become negatively charged and become nucleophilic. So this nucleophile can be secondly added to the next carbon aromatic aldehyde, and it form an intermediate structure like this. Then in presence of water, this oxygen can undergo an acid-base reaction, and it form an hydroxy compound. Then in this hydroxy compound, it give an hydroxy OH minus here in the system. That OH minus we can undergo an acid-base reaction. Then it can remove this hydrogen hydroxy group. Then it become O minus. That O minus can expel this cyano group, and it form finally a benzoin. So why aliphatic aldehyde is not reacting like this to form benzoin? This is due to extra stability of this carbanion, and this carbanion can undergo delocalization with the cyano and also with aromatic ring, that is benzene ring. So it is extra stabilized, this carbanion. So that is the reason for this unusual formation of this carbanion. And also, what is the characteristic? One of the characteristic of this reaction is actually the role of cyanide ion. And cyanide can act as a nucleophile, and at the same time it can stabilize the intermediate. And third one, at the same time it can also act as an leaving group. So benzoyl condensation also can be done by using some heterocyclic compound like thiazolium salt. Instead of cyanide anion, you can use thiazolium salt like this. So aliphatic aldehyde with alpha hydrogen can undergo benzoin condensation with thiazolium salt, and it form an benzoin like structure, that is 1,2 molecule condensed to give and benzoin like structure. And here thiazolium participate in a reaction like CN minus like this. This thiazolium can act as like a CN minus, and it added to the carbonyl of this compound, and it form a carbanion. Then that carbanion added to the next molecule of this aldehyde, and it form a structure like this. Another question in benzoin aldehyde condensation. In this particular reaction, what would be the product? Can you think what will be the product of this reaction? And in this particular reaction, this can act as a base, thiazolium salt. Then it will be added to the aldehyde. And this aldehyde, this carbon can form a carbanion. Then this carbanion will be added to this carbonate. Then it undergo a cyclization step. And product will be like this. So you can see here carbon-carbon bond is formed here, and one carbon will be carbonyl, and next carbon you can see the hydroxyl group. Hydroxyl is from this carbonate. So question 2, you can see two aldehyde within the same one molecule. In presence of this thiazolium salt, it can also undergo a cyclization reaction. First, this one of the carbonyl become nucleophilic on reacting with the thiazolium salt. Then that carbonyl react with carbonyl of the same molecule. Then it undergoes cyclization. Your final product will be this one, because this is unstable on reacting in the presence of air. It can, this hydroxy become carbonate. This is the final product. So next class we will discuss next lecture series, Darson condensation. That's all for today's lecture. Thank you.